This week we are going to start the class, okay, class and object. So in the first 10 chapters, we are talking about the design inside a function or inside a class. Okay. So pretty much the first 10 chapter we are talking about there is a function, and then inside the function, what are the data type? Okay, what are the data type? And we also talk about the program structure, the if then else. We talk about the for loop. Okay, that's inside a function. So last week we talked about function design, and then this week we are going to talk about class. So class is bigger than function. So whatever inside the function already been done so far. Now we are starting to look into the combination of the programs and also the data structures. Okay, so we will talk about class today. Okay, so we are targeted in looking into the more complicated program structures, not just a function itself. Okay, so a function is a paragraph, just like a paragraph in English. A statement is a sentence. Okay, and now we are going to talk about a class. A class actually is a essay, a article. Okay, so it's a bigger unit compared to function. Inside a class, there will be multiple functions. Okay, may have multiple functions. May have one function, may have multiple functions. Okay, let's look at some example. Okay, when we talk about some data, sometimes we actually, for example, we want to calculate the distance of the 2 points. There will be a point on a two-dimensional plane. Let's assume that is a point 0. The point 0 has x0, y0 for coordinate. There's another point that's called P1, and it will have x1 and y1. And we would like to calculate the distance. Okay, so you can use bubble, okay, x0, okay. Okay, so you got this x1, y1, x0, y0, and you can calculate distance. So let's calculate this. So bubble distance equals distance. Okay, you pass the 4 value to there, so x0, y0, x1, y1, okay? And then you need a function. Okay, you pass these 4 parameter there, and you are going to return the distance of these 2 points. So you will have double dx equals x0 minus x1 double dy equals y0 minus y1. Okay, this one positive, negative, it doesn't matter. Okay, and then you will return. Okay, that's the square root of dx times dx plus dy times dy. Okay, and then you will print out the distance. Okay, so this one is a printf statement that will print out the distance between the 2 points. Okay, and you write this program. So you basically declare 4 variables, and then you actually calculate the distance between these 2 points. Anyway, these are fine, but the problem is if we have more than 2 points, if we have say 20 points, then you need to have a 40, totally 40 double value declaration. So that would be very tedious. That would be very tedious. And then if the point go to 200, then there are 400 double value you need to declare. That actually is not efficient. Okay. So if we continue to use this kind of the primitive data, then that's not enough. So then we need to have some concept that's called structure or record. So in the old day, the C language come out with the idea of structure. So a structure is the predefined data type or point, and each point will have x and y, and you can declare a value of with the 2 data field x and y, and that representing the point. So this one in C language we call it struct. In Pascal language, we call it record. Database is also called record. Record is organization of data, putting a few data fields together. Okay. But in Java, we don't have structure, we don't have record. So Java use the name class. So class is in use in place of the structure and record in different languages. Okay, so that's what we need is a class. That's the beginning part of the struct class is the organization of your data to help your data more organized. So this one, when we talk about chapter 3, we talk about object. We already talk about it, but it's okay. Here we will repeat to give you the idea of what it is. Now, let's look at the point class. So you declare a class. A class actually is a collection of data. You want it to be representing a data point. So it comes with a single mission, single concept. So let's assume that you have X and Y. Okay. If you don't assign value to it, they will get initial value of 0.0 in Java. Okay, in Java, if you don't assign value to it, and it is a instance variable, then you will get the 0.0. Okay, so right here we declare two instance variable. These two belong to a object, okay, belong to an object, and these are two data field for a point. And then you need to have a constructor. In constructor here, you do not have a return type, not even void, okay, not even void. They don't have double, they don't have void, they have nothing. You don't put anything there. If you put public, that's fine, but you don't need it, okay? And then you may have the value of double X, double Y, okay? So this we call it constructor. So constructor's purpose is to initialize the object. Okay, so this one we call it constructor. So you pass the value of X, Y, and then you try to initiate your X and Y right here. Okay. But right here, we use the same name, X and Y. So these two are considered to be two different variables. If you do this, if you do X equals X, and then Y equals Y, then this X and Y are actually this X, this Y, this green X, this green Y. So you are assigning your value to yourself. This one doesn't work. Okay, you cannot do this. So if you want to assign a value to this X here, let's assume this is called red X and red Y. If you want to assign the value of the green X to red X, then you have to use this, the X called X. The current disk is current objects X and current objects Y. You assign the XY to it. Okay, and then this will build a object for you. Basically, you'll create an object in the heap with the SY value. Initial value is 0. But when you assign this green SY there, you actually assign the green SY value to the object. Okay, that's the purpose. Okay, these are actually, let's assume that this is a very basic class. Let's just start right here. Then you may assign a tester for it. Let's assume that there is a test point. Okay, so now you got a point. So this point is a class. And in a way, it also is a data type. Just like your integer is a data type. So you can create a data of this type. So let's assume that we will actually create point P1 equals new point. So this new point will call the constructor and then pass the value from here to the object. So let's assume that right here, you actually pass in the 3 and 4 there. So in a way, you create, by this one, you create a object. With the coordinate of 3 and 4. Okay, now let's go back to this point data. So right here, you have the 3, 4, and then the other point is 2, 5. So you can create another point that actually is 2, 5 right here. Okay, so class is an organization of the data. It is also a data type. And when you call the constructor, you will build an object and assign a value to it. So actually you create an object of 3, 4, and then you will actually assign the reference address to P1. Okay. So you got 2 points. Now you can calculate the distance between these 2 points. Let's actually put a function right here. So we got 2 points and we want to calculate the distance. So double dx equals p1 dot x minus p2 dot x. Double dy equals p1 dot y minus p2 dot y, okay? And then you return match that square root of dx times dx plus dy and dy, okay? So this one is a static function. A static function providing service to 2 points. P1 and P2, okay? So in a way, this function is the same as the distance function right here. Okay, it's actually the same, but you pass 4 value there, but right here you only pass here you only pass 2 points over there. It's better organized. Okay, so let's copy this portion over. Put it over here. Okay. So basically, you calculate the distance, and then this distance function, you actually use P1 and P2, and you pass to the function, and then you will calculate the distance. So right here, you actually calculate the distance between this and this, and then you put in the x and y. Okay, now we can change this one to percentage s, and then we'll put in P1 and P2. So you want to print out the data of the P1 and P2 and the distance. Okay, now P1 is the object, but you cannot print the P1 object. So you have to use a toString function to convert an object to a string. Okay, so to convert an object to a string, you go to your class and you need to provide a toString function. So this one is called public static. Okay, let's do it first. Let's actually don't give the toString function first. If we don't give it the string function, then let's look at what will be printed. So if you don't give the string function, then they'll give you a point object at certain ages. Okay, these are the default object class toString functions as a result. They'll give you the point object type and then the ages of that object. So this is not readable for us. Okay, this actually is not readable for us. So let's look at it. So you want to print out the data. So you actually need to have the toString function with the public string. toString. Okay, you will convert the object to string. And here you return. Okay. You can use you would like to have the format just like your printf. This you can use a string.format. Okay, and then put your format string right here. You actually do bracket comma %.2 f %.2 f. Then this one will provide the converter object to this format. Okay, and then you put your x and y there. This x will be used to replace this format. This Y will be used to replace this format, okay? So with that, you will have a toString function, and then this point class at the edges will be replaced by the toString functions result. So you compile and run, you get this. Okay, now it seems that this should be 5 to be consistent with my previous example. Let me change to 5. Okay, so this give you the same result as the first program. Any questions so far? Any questions so far?
No.
No.
So no question. Let me ask a question for Harrison. What is the purpose of having a class?
So you could like easily access it over and over again.
How about Belinda? What's the purpose of having a class?
So you can create your own types of objects.
Okay, make sure you understand it, okay? So these are a point. You come with the data field. These two data fields are the data field you would have, a data field for the SY. And its constructor's purpose is to fill the data into here, give you the initial value. And then this the toString function's purpose is to convert this object to a string format when you need to print it as a string. Okay, these are the first most basic idea of what they are, and we use this as an example. Okay, now this static function outside the test point, we can actually cut it. Okay, because this function is to provide a service for any arbitrary 2 point. So we can put them right here after the toString function. Let's put this static function over here. So this one is it doesn't belong to any object, but it will provide the service for 2 points. So we put into the point. But because it is a class function, so right here you need to put a point class that distance before it. Okay, if you put it in the same class and you want to call the function defined in the class, so you actually need to use the class that function name to call it. That will call the function inside here. Okay. So this one we call it static function or a service function or a utility function that provide a calculation of the distance. Now, sometimes we actually calculate a distance, say there's a P2. How long the P2 from P1? Okay. So we may not like to have this distance function as a static function. We may want it to be a instance function. So you take out of the static and just put a P right here. You just put the destination P and you change it to S or S minus P1.x and P1.y. Okay. So this one is a instance function. This is different from the static function. Static function is a class function. So class function provides a service between two points. This instance function is a function belonging to current SY. So you're calculating the current SY versus another point called P1. You're calculating the distance between them. So in real use, you come to here, you actually do this. You do, so here, let's call it double distance 2 equals P1's distance to P2. Okay, let's copy this whole line. and put it over here. And then here, let's put the distance 2. So this one, we call it a class function. This one is a instance function. So instance function, you calculate the distance of P2 from P1. Okay. And this class function providing the service of distance calculation between the P1 and P2. This actually, the nature of the calculation are different. But you can do either way. Okay, you put a distance function as an instance function that you always calculate the distance with respect to the current object, or you calculate the distance between two classes, two objects. That actually is either way is fine. Okay. Okay, so this one, they deliver the same result. Any questions so far?
No.
Okay, so this chapter 10's main purpose is talking about how to design a class and how to use a class. Okay, and class is a way to organize your data. Okay, to organize your data. And then so far we talk about string. String actually is a class. We talk about integer array. Integer array is not a class. Not a class. Okay, so far these two types. Some is class, some is not a class. Okay. So string is a very special data type. It's a class, and it's also work like a primitive data type, but it's not the primitive data. It actually is an object. Okay, it actually is an object. Integer array instead, it actually is a primitive data type, but it's an organization of the data, but it's not a class as well. Okay. Now, so right here, we actually have no class. Point data is no class. Then we have a point that comes with a class. Okay. And then we have a tester to test it. Okay. Now let's use another one. Third example is we don't design our own point. We don't actually put it unorganized. That's actually use okay, they use a class called point2d. Is in AWT. Let's see, it may be called point. Okay, let's call point. It's not point2d. I think point2d is in swing. Okay, let's use the one defined in the AWT. So here let's actually call it AWT point. Okay, so this is a class defined in the AWT is called point. Okay, so point. So this point, let me actually zoom in. So point has a constructor, and point has two data fields, integer x and integer y. Okay. And point has a constructor, point has equals function, point has get x, get y, move, set location. Whose string translate different okay, and then there is another one called AWGW. There's a point2d, and point2d there is a distance function in the point2d. Okay, okay. Anyway, okay, good enough. So let's assume that we actually import the AWT point class. So instead of using the point object defined in our class, I would like to use the point defined in the AWT. So I would rather use this. Let's call it java.awt.point. Okay, p1 equals new java.awt, including the domain name. Okay, including the domain name, and then here for the 3 and 4. Let me copy from the test point. Okay, right here. Copy this whole thing over. So this is a point one I already used. Let me delete it. Okay, now let's define point two. So point two use the same thing. Okay, now we want to call the distance function from the other class. This one is called AWT geometry point 2D. We want to find the distance function there. And let's see. The distance function has a dx dy. It is an instance function. Okay, it is an instance function. Okay. So here, this one no longer. Okay, let's delete it. Okay. So by using this, it already had a distance function from the geometry package. So this one I don't need to design it. It actually come from this distance function or come from the point class. Okay, let's look at how this one works. Okay. So this one is using other people's class. Okay. So it's quite different. Is that their toString function is different from us. Okay, you convert the object in this format. That's not the toString function that I denied. It's actually from the java.awt. Is that okay so far?
Yeah.
Okay. So let's keep it in this way. This is AWT. Let me copy this one. And let me create another class. Let's call it point AWT2. Okay. Let me put it over here. Okay, in fact, because I already included, so this actually is not necessary. Okay, I can delete that. I just want to show you it is a point from that class. That's not my own design. Okay. But in fact, you don't need that. You actually can do it in this way. Okay, you will deliver the same result. Any questions so far?
No.
So what we covered today is like the first example is unorganized data. Okay, the data is unorganized. There is no class to organize it. Second one is that let's use a class defined by ourselves. That's our class and object. Okay, and it will deliver the result. And the toString function is defined right here to convert the object to string. Okay. And now third one, actually, we use the point definition from the AWT. AWT is Java abstract abstract, I'm sorry. Abstract. Windows Toolkit. So it's a version 1, it's a window join kit. Okay, so it's AWT. Okay, but it's already very old. They are newer design. Okay, they are newer design. But this just to show you that the point can define from other people's class. Okay, other people's class definition. So in a way, the Java class main purpose is to organize your data. Organize your data and make it reusable. Okay, make it reusable and making your programming more organized. Okay, that's the purpose of that. And then this whole chapter is dedicated to talk about the issues of a class and object. Okay, that's the main purpose. Now let's go into the slices. So you will talk about the abstract program design, impacts of program design, autonomy of the class, what is the constructor, what is instance functions. These are required by the College Board curriculum. Okay. Also, we will talk about what is the static program, what is object-oriented programming, what is instance variable, what is instance method, what is type of classes, what is the readability and scope, and what is the array of object and object of arrays. Okay, these are different topics that we cover in this chapter. So basically talk about what is a class, what is an object, and how to design them. These are 3 major topics, okay? Now let's change gear. Let's don't use a point. Let's use another one. Let's use let's use let's use a okay. Let's use a class called bank account. So when you open a bank account, you may need to have a name for the person who owns the account. So there's a name. You may have a balance. So let's use a double, okay, balance. Okay, let's don't make it too complicated. So let's assume that we have these 2 in data field, okay? And then we may have a constructor. You will initialize these 2 values, okay? So let's have a string name and then a double balance. So your name will be name, balance will be equal to balance when you open the account, okay? So we have a data field, we have the constructor. Data field is the basic data that you would like to store in the object, okay? And then you have constructor to build it. Now, this is a class. Bank account is a class. Now let's create another class called test bank account. So test bank account class is a tester to test the bank account. Okay, so first account let's belong to Ariel. And she put the $1,000 there. Okay. Then we have a bank account BA2. This new bank account. Let's put Brian $500. The third one is have the account for Carol. Let's assume that she has $1,500. Okay. So now bank account itself is a class. And you create three objects. The three objects are BA1, BA2, and BA3. Okay, so BA1 belong to Ariel, BA2 belong to Brian, BA3 belong to Carol. So the bank account actually is a class. Class is a template, just like your blueprint to build your house. So class is a blueprint to create a bank account. So your bank account will be built based on your objects BA1, BA2, BA3 will be built based on the template of the class bank account. Is that okay?
Yeah.
Then this BA1, BA2, BA3, they are objects. This we call it object. So object and class are different. Class is a template. It is a machine that print money. And then object is the money that you print out. Okay, so these are of different concepts. Okay, you have to understand it. Okay, if you don't get confused by the class and object, then you are in big trouble. Okay, now, so each account has some balance. Each account has the name. Okay, so let's go to there. So your bank account may have getter functions. What is getter function? So public, okay, string, get name. You can get the name of the account. So this one you return name, okay. And then you have public, okay, string, okay. Get the balance. And this one you will return balance. Okay. These are getter functions. So let's try getter functions, okay. This one actually balance is a double type. Let me return that. Okay. So here you have BA1 that get the name, BA1 that get balance. This is for you to get your balance and name. So basically you have an object called BA1. You put the name in there using the constructor to put the name and balance there. Okay. And then you can use the get function to get the name out or get the balance out. Okay. To retrieve the data from the object. Okay, so this print out Ariel have this amount of money. He or she actually, we don't have a male female difference. Okay, right here. Any questions so far?
No.
So this one show you the getter. Now let's try setter. And the account may also have a setter. Getter is to get the data from the object. Okay, setter is to set the data. So Huckleberry boy set name. So sometimes your accounts person may change name. So you will update your name. Your name will be updated by N. Okay. And then you may have, okay, here balance. Balance, you update the balance, but usually you will use a deposit or withdraw. So let's use a deposit or withdraw. So let's assume that you do deposit. Okay, let's assume that you deposit an amount, double amount. Okay, then your balance will plus equals the amount. Okay. Now withdraw. So you want to withdraw the amount of money. Now withdraw, you need to be careful. You may over withdraw. Okay, so you need to do it. If your balance minus amount less than 0, then you will print out. You will do this. You will return. Okay, for sure you break the program and you print out. Okay, over withdraw attempted. But you don't really withdraw it, okay? So here you say in denial. Okay, now if you do have the amount of money that you want to withdraw, so your balance will minus equals amount. Okay, that's a withdraw. So these two are also setters. Setter means that you will set the new balance. So setter is to modify your data fields. Getter is get the data from there, so they won't change your data. Is that okay so far?
Yeah.
Okay, so let's try it, okay? So now this Ariel have $1,000. So let's do BA1 that withdraw. I'm sorry, something wrong. $500. Okay, then that's actually printing out the balance at one time. And that's withdraw 800, okay? So these 800 supposed to over withdraw. Okay, so basically 500 withdraw, 800 actually attempt got blocked. And then the account remaining to be $500. Is that okay so far?
Yeah.
So this is the getter and setters. Okay. So what I'm trying to do is teach you what is instance field, what is constructor, what is getter, what is setter. Okay, now this one is the some functions that usually you would need to have. Okay. So the first function is the toString function. Okay, this one, let's assume that we don't have the toString function yet. Let's just demonstrate one more time. If we don't have the toString function, and right here, I want to print the BA1. I just directly print BA1. What will happen? Okay. What will happen is it will print you the object at some ages code. Okay, the bank account object at some ages code. Now it's okay. Now if I do this, if I do the toString, it is okay, but this one actually get the toString function from object class default function. So what it means is the toString function, you can call it, but you will get the definition from the object class, and it's still the class at the ages code. So that's not what we want. Okay, so this one that's coming down. Now we want to have the contents. So that's actually turn on this toString function. So you can define your own toString function. If you don't define it, you will get the class at some ages code. Okay. Okay, so this one will be your toString function. So this one, let me try to write another one. Okay. I should just hide the BA1. So this toString function is every object's basic function to print your format. Okay, to print your data. Is that okay so far? You must define it. If you don't define it, then they will give you the object class definition. That will be class name at some ages. Is that okay?
Yep.
Now, next one. Next one, sometimes we would like to compare two accounts, whether they are equal or not. Okay, so now, you may, let's assume that there is no equal function. Okay, no equal function. So let's see. No equal function right here. Let me create another one. Let me create a bank account BA4 equals new bank account. This one, let me also put the Arial and 500. Okay, 500 because here we already restore 500. Okay, so let's assume that we use this now. Now, if we do this, if we do system.out.println, BA1 double equals BA4. So the result of BA1 equals BA4 would be false, even though the data is exactly the same. Because this double equal sign will be checking the ages of their object. They don't care about the content. Okay. You got a false. Okay, now let's try another one. So right here, let's copy this one. And let's don't use this one. Let's use that equals. So that equals, it will still be comparing the ages because you do not have your definition of that equals. So they will use the definition from the object class and they will compare the ages again. So this one is also a false, even though the content is the same. Is that okay so far?
Yeah.
So this equals function and double equal sign both doesn't work. That's not what we want. We may want to have a function that actually can check it. So right here, you need to override the definition from object class. So you need to provide a public Boolean equals, okay, bank account. Other. So current account compared with other accounts. So return this dot name that equals other dot name. So the name need to be the same, and this dot the balance that equals others balance. Is that okay?
Yeah.
Oh no, this actually balance is the, I'm sorry, this balance is actually is a double value. So you don't have the equals function. So you have to use double equals. Okay, anyway. Then you compare the name and the balance. And then this equals now become true. BA1 and BA4, they check the content, it's true. Okay. Now let me actually create another one. Here, let's actually create another one. Let's call it BA5. So this bank account file maybe is done by Daniel. And then Daniel also has a $500. But Daniel and Ariel are different person, right? So if you compare their equals, they will not be equals because they are different person. The name is different. They have different ID. But sometimes you don't compare the equals object or equal account. You do want to compare the equal amount. Okay. So you don't care about the name in a way, you don't care about the name. You only care about the balance. Who owns the account doesn't matter. You just care about the balance. That's equal amount. Okay, come back to here. This actually, when you define equal, there are several definitions for equals. You got to know about what do you mean by the equals. Is that the equal object or equal address or equals contents or just equal amount? Okay, so here let's do equal amount, BA5. Okay, BA5 and BA1 owned by different person. Okay, BA1 and BA4 owned by same person, same amount. Okay, BA1 and BA5 different person, same amount. Is that okay?
Yeah.
So when you design class, you have to go to the details to think about different situations that may happen. Okay, different situation that may happen. So right here, I'm going over this basic getter setter, public methods, and this instant PO and constructor. Okay, I'll send it to you. Let's have a break. Come back on 9:07 p.m. Okay, I'll send this code over. You take a look, okay? Because if you don't take a look, you actually may get lost. Come back later, okay? I'm going to send it right away. Look at the different classes, okay? Making sure you understand them. Okay, any questions so far?
No.
So today we go over the design of a class, okay? How to design a class. So basically, a class is a collection of data fields. Usually there is a reason that you want to design a class. For example, this point class, you want to have a data type called point, okay? And bank account, you want to have a data type called account. Okay, so account has a name and account has a balance. Now let's look at class variable and class functions. So class variables. So class variable is a variable that belong to a class, doesn't belong to an account. Okay, so basically now you have a bank account class. You do create a bank account BA1, BA2, BA3. So BA1 has BA1's balance, BA2 has BA2's balance, BA3 has BA3's balance. Each one has an owner. They have a different owner, different balance. Okay, now, what is the bank account's class variable? Okay, that is some data that is shared by the accounts. Usually it's some data that's shared by the accounts. So what are the data that shared by accounts? Let's assume that there is something called, let's create an integer. Let's use a static integer account number. Okay, let's initially set it to be 0. So when the constructor being called, your account numbers will increase. This means one new account. So this variable, how many account already been created? This variable account numbers doesn't belong to any account. Okay, your balance one that belong to area. Area doesn't own these account numbers. This account number owned by the bank. This type of variable we use as static is a class variable. Okay. So let's see. Let's go back to our test account. So right here, let's initially put in the system.out.green line Okay, you want to know about how many account already been created. So right here, we use you need to use a bank account as a class name that class variable names. Okay, you print out the bank accounts account numbers. This should be printf. Okay, so initially you print it, and then that's after one account created. Let's put it here. Okay, and then after 5 account being created, let's print it again. Okay, let's check. Okay, so this type of variable belong to the class. It doesn't belong to the object. This one we call it class variable. We also call it static variable. Okay, this two doesn't belong to the class. It belongs to the object. We call it instance variable or object variable or data field. Is that okay?
Yeah.
Or sometimes non-static variable. Okay, this is the so-called the so-called class variable and instance variable. Now let's look at the so-called static function. Static function provides service to some of the class, but it doesn't belong to object. So right here, let's actually do this. Let's create a function that's static. So sometimes we want to know about the balance of two accounts. So this is a service between bank account 1 and bank account 2. It doesn't belong to a certain bank account. So this one is something like that. So your return, okay, BA1 that get the balance minus BA2 that get balance. But sometimes you want it to be, say, let's assume that you actually would like to know about the absolute value. So let's put the absolute value. Okay, just want to know about the difference. We don't want about it's positive, who actually more than the other one. Okay, so this one is a balance. So this is a balance difference function. It's checking the balance between two functions, two accounts. It doesn't belong to bank account 1. It doesn't belong to bank account 2. It belongs to the class. It is the class service routine. Provide service to two bank accounts. Okay, so let's try this. So now it's a class function, so you need to use the class name called bank account. And then the function name dot function, the function name is balance difference. And then you put your BA1 and your BA2 there. Okay. BA1 and BA2 is 0. Or BA2 also $500. It's okay. 0 is fine. 0 is the right answer. Any questions so far?
No.
So right here, we go over the instant data field, class variables, class functions, getter, setter, and also the constructor, also the object classes function, toString function, and equals function, equal amount function. Separate way of checking the equals function, okay? Sometimes you may also have a static double interest rate, okay? 2% interest. So this interest can be a class variable, can be an instance variable, okay? Sometimes different account do have different interest rate. But sometimes the whole bank has the interest rate. That depends, okay? That depends. Depends on this interest rate is a global interest rate or someone's own interest rate. So that depends, okay? But here, let's assume it is a shared common interest rate among different classes, objects, okay? Okay, right here, we just go over the class slightly. Okay, let's go to the slices now. So this is basically how to design a class and how to use a class, okay? How to use a class, an object. So usually this object-oriented programming is used in the Windows environment because Windows, you need to use a lot of libraries designed by other people, okay? And in APCSP, in APCSB, we'll teach you how to write a graphic design user interface. Okay, we will teach you that. And object-oriented programming sometimes also bundled with event-driven programming, graphic user interface design. Okay. And it is used to replace the library, data record, event loop, and the thread execution control. Okay, several different topics. So this one AP don't test, this one AP don't test. Okay. But you may need to know. So object-oriented programming involves programming using object, an object representing entity that is in real world that can be distinctly identified. Okay. So that can be a student, a desk, a circle, a button. Okay, that actually is a object you can design. So basically, an object is you may have a button, 2 button, 3 button, but this 3 button all belong to a class called button class. So button class is a class to create multiple buttons. And each object is a button, okay? So here we have a class called circle, and circle class can create circle 1 object, circle 2 object, circle 3 object, and each one has its own radius. So this one we call it UML, Unified Modeling Language. Okay, Unified Modeling Language. This is called super UML. This is UML class diagram. So in here, you list down your data field. There's only one data field called radius. Constructors, your circle constructor, circle new radius constructors. Get area, get parameter. These are 2 getters. 1 setter function. Set radius. Okay? Any questions so far?
No.
No.
So this class diagram usually is designed for engineer to be able to understand what is available by the class. As for how this class is implemented, you don't need to know. You just need to know about how to use the class. Just like when I call the point class, I don't need to know about what the AWT really designed a point class. I just need to know how to use it. Okay. And because when your graphic library get bigger and bigger and bigger, you cannot always design your own graphics functions. So you have to rely on these libraries and calling them. So you must know about this UML and know about how to utilize the object. Okay, you must learn it. So classes are constructors that are actually the template that can be used to construct the objects. Okay, building the objects. And when you build the object, you use the constructor to build it. Okay. And in C language, C++ language, there's also a name called destructor. Now, when you finish using the object, you can delete it. Okay, that's called destructor. But Java don't have the destructor. Java use object collection. So the unused object will be collected, will be recycled. Okay. So just like Java have some sort of cleanup mechanism by itself, keep cleaning up the unused object. Okay. C++, you have to destroy the garbage you create by yourself. So here is a simple class. You have a class circle. There's a constructor, two constructor. Okay. This one, that constructor name with no parameter and no function. This one sometimes also called default constructor. What is default constructor? Let's try, okay? Let's assume that there is a class called square. And this square, I only have one data field. Let's call it integer side. That's it. So this class, I just declare like that. And then I create a tester. Let's call it tester square. So now, this square class only have one data field. There are no constructor. But if I do this, if I do square s1 equal new square, is that okay? That actually is okay, because let me print it out. Okay, let me print it out. This one you call a new square, but there is no square constructor. So what will happen? What will happen is that you will run the default constructor. So there is a default constructor called square. No function, this one. It's okay?
Yeah.
This one, you write it or you don't write it, you get the same thing. Now, if you do this, if you do square an integer ss, and you say s equals ss, so you build a constructor, and somehow you deleted this one. and you try again. Now it doesn't work. It no longer work because there's no one argument constructor. There's no argument constructor. Because the default one, if I design a one parameter one, then the default one is gone. So you must have this one here. Okay, if you don't want to design, you don't design. If you design, you will get one. This is a side. Okay, side. Okay. So basically, if you don't design, you will get a default one. If you design with one parameter one, then you want to have the default one, you have to write it back. You got to write it back. Otherwise, the no parameter one already gone. Okay? Is that okay?
Yeah.
It may override the default constructor. Okay. So these are the rules I want you to know. Okay? These are very important rules. Okay, up to there. Let's continue. Okay, there's tons of slices that we need to finish today. So that's about constructor. You may have no argument constructor, one argument constructor. So constructor, usually the one without constructor is called no argument constructor, and the constructor may have the same name but different parameter list. Okay. And so you may have a new class name to create an object. So new circle or new circle 5.0, they are called different constructor. Okay. Okay, now reference variable. The third concept. So now square is called class, right? New square is creating an object. While this S1 is called reference variable. Okay. These three are different. These three are different. Okay, these three are totally different. So what is the difference? Let's assume that you want to build a building. So you want to build a building, you do have a blueprint. So your blueprint look like this. There's a room, there's a door, there's a living room, there's a kitchen, there's a sofa, okay, whatever. This is your blueprint. This is a class, right? You use this blueprint to to build multiple houses. Of the same model, you build several houses of the same model. Okay, so each one may have different ages. Let's assume this is H3, okay, number 1 H3, number 2 H3. Okay, let's assume this is a H3. Let's assume this is B street. So this one is a number 1 B street, number 2 B street, number 3 B street. Let's assume that. Okay. So the building itself is the object. The class is the blueprint, while the reference variable is the address. So there may be a building with number 1 H3 and number 1 B3 address. So one building may have two reference variable holding. Is that okay?
Yeah.
Is that okay? So reference variable is different from the ages. Okay, let's try it. Let's go back to point. Okay, first one. Point is a class that we define. Yeah, that's no problem. But I create a point reference A that holding the edges of null. Null is nothing, actually it's grounded. So when you print this one, what will happen is it's use point. Let me put it here. It's holding the edges of no building. So it's null. Is that okay?
Yeah.
So A is a building address, but this address right now has no building associated with it. Is that okay? That's okay. That's definitely okay. Now later you can have A equals new point 3, 4. Then you build an object for it and you assign the address to it. That address is fine. That address is fine. Okay, so initially your A variable is null, you point it to nowhere, you ground it, or parking. Sometimes we call it parking. And later you create a object of 3, 4, and you point into it. That actually is fine. Okay, so you actually assign some object to it. Now if I create another one, as let me call it pointer B equals A. So what happened to B? B is another variable holding the edges of the point that A is pointing to. So basically the edges over here being copied to it. So B also pointing to the same object here. So it's one building, two edges situation. Is that okay? This is one building, two edges situation. Copy the edges of A to copy edges of B. Okay?
Yeah.
So in this case, if we change the value of A, say A dot set, no, A dot X equals 10. Okay, we set the X to be 10. Let's print out A again. So A become 10, 4. This one, let me use a print line. Okay, print line. Now, if I print B as well, let me put it here, okay? Let me put it here. So B also got changed. Let's actually review the whole case. Initially, your A is grounded null. Then you create an object called 3,4. Then you point into here, you actually break the these. Okay. And then you actually create another B that's pointing to the same edges right here. Then you change the X for A that change it to 10. So B also C. Is that okay?
Yeah.
So what I want to say is class, object, and reference. These three are of different concept. Class is the template. Object is the entity. Reference is the address. These three sometimes means the similar thing, sometimes different. You got to be very careful. Okay. If you don't understand it, you better draw a diagram to see what happened. Is that okay so far?
Yeah.
Okay, that's the reference variable. Okay, that's the reference variable. Reference variable is the variable that holding the address of the object. That's what it is. But sometimes you're holding null, sometimes you're holding object that already been defined by other object. Okay. So when you create object, this right-hand side create an object in the heap, while the address being stored in my circle, and my circle pointing to it. Okay. And then you can get the data of the my circle's radius, my circle's methods. Okay, these are instance variable and instance methods. So right here, you declare a my circle equals new circle 5.0. You declare my circle with no value, and then you call the constructor. The constructor put a value of 5.0 to the my circle's object, and then the address being assigned back to my circle. And then you create a your circle equals new circle default constructor. So default constructor no radius set to be 0.0. Okay, so yes, okay, default is 1.0. And then the address being assigned to your circle. So now your my circle point to 5.0, your circle point to 1.0, and then you update your circle's radius to 100. So you update this one to 100. Okay.
Wait, why do you need getters if you can just use like dot radius?
For security.
Oh,
Yeah, later
sure.
we'll talk about public and private.
Okay.
Some
thanks.
data you don't allow people to directly access the variable. Okay,
All right. Thank you.
we'll talk about it later. But at this moment, either way will work.
Okay.
Okay.
Mm.
Okay, we talk about a static member class method or not. Okay, so this is a mass.awabsa dot rounded function, mass.power, mass.sqrt. They are all class variables, class functions. Okay, the mass class has a big collection of service routine for everybody. Okay. Okay, next one is static functions. So one way to organize the program is one way to organize your function program is that you do use a lot of instance variable, instance functions, and something like that, right? There's another way that you organize your function is by static functions. So in the old day, like C language, everything is static. So there's no class. So in that case, usually everything is just function calling function. So these are traditional programming. You just use a function and programming to publish static rolling. Okay, string the right yes. So this one is a pure static function. There's no object, no instance function, everything static. Okay, so what happens is that you go main function, go to here, print it, and then go to square function, run it, return. Come to the next one, go to cubo function, go to here, run it, and then finish and return. Okay, so this one is static function calling static function calling static function. This is traditional static program. Is that okay? Hello?
Yeah.
So this one we call it structured programming. Just use if then else for loop, while loop function code. So usually you go user code just takes you this kind of the static function programming. Okay. Now today we learn a different thing. The different thing is called it's called what? Object-oriented program. We design an object and then run the objects. This is different from the structured programming. So this one, we go back to another one. Fundamental sense. Like when people talk about structured programming, object-oriented programming, neural network, Faraday logic, this different term, we call it paradigm. You may not heard the word paradigm. Here it means programming paradigm. So existing programming paradigm, including structured programming, event-driven programming. Okay, and then neural network. And then fuzzy logic. Okay, data flow programming. And then functional programming. So these are different programming paradigms supporting AI mostly, but they are of different way of writing program. The concept is totally different. Java actually support structured programming, event programming. Lightly on functional programming. Here I make a mistake. It's neural network. Okay, this one's neural network, not network network. Neural. Some of the Java doesn't support. Okay, so this is different programming paradigm. In terms of programming paradigm, you need to learn different programming skill. It's totally just like different language. Okay, just like different language. Is that okay?
Yeah.
So in a way, let's actually go back to the first one, our program. So in a way, this one static, this one actually is a traditional structural programming, right? You don't have class. While this one is object-oriented programming. You do design object before you do programming. Is that okay? So sometimes you use the object-oriented programming, sometimes you use the structural programming, sometimes you mix them together in Java. Okay, depends on how you feel it's better and easier to solve the problem. Okay, so now we give you the idea of what is static programming, function calling function. That's one way to do it. Later, we will show you more example of different way of doing programming. Okay, so this part, I don't want to spend too much time, just function calling function, okay, static functions. And it's possible that you do object-oriented programming. So object-oriented programming is sometimes also called data-centered programming, because you create something called point. And that's actually work on points. It's data center. While structured programming is this function calling another function, calling another function. It's more procedural programming. The two fundamental way of doing programming is different. Okay. And can you have a class, say this class called physics class, it only storing quite many constants, no function, no other things, just constants. Is that okay? That's okay. That's perfectly okay to store all of the physics constants. And the class just use phi dash c for the light speed of light. You don't do any programming, just providing the constants. That's perfectly okay. Okay. When we do physics, there are tons of different constants. You want it to have a collection, so you put it into the PHY. That's okay. You may want to design a 2D vector or a complex number or a phasor. Represent the coordination, different coordination of the same point. Is that okay? That's actually perfectly okay. Okay. But right here, we are not teaching you this kind of advanced math, okay? But later, when you really go into the math and science, you may need them, or engineering, you may need them, okay? Just give you the idea of these are different data vectors. You may have a student class with the name, student IDs, ages, score, grade, and then class name. Class name is array list. Multiple class. Is that okay? That's okay. GPA is okay. That's okay. So this is one class as data collection. So when you design a class, you may already know that you want to have a class for student. And you put all kind of data here. So you start with the data, then you design the getter, setter, equals, toStrings, service routines, okay, based on this whole thing. Okay, right now we are not doing it, but just let you know that that's the way we do object-oriented programming. We don't think about who calls which function, call which function. We think about how to design a class for other people to use. Is that okay?
Yeah.
So that's an object-oriented method. You kind of designing object with attribute. Attribute are data field. Behavior are the functions. So you have the object with different value and different functions. Each one talk to each other. It's called object-oriented environment. Later, we'll show you how to develop a pure OOP program. Okay. So far, the for loop, while loop that we talk about, it actually is not OOP, it actually is structured programming. Okay, so far, chapter 1 to 10, we talk about structured programming, nothing to do with OOP. OOP is new, totally new right here. Okay, we'll talk about OOP later. So reference variable, we talk about it, null value, we talk about it, this we just pass. Garbage collection. When your object is not used, we call it a dangling object. Okay, dangling object. So what is a dangling object? Let's show you a dangling object. So let's assume that we create a point. Okay, now later, so here we do a lot of calculation, okay, tons of calculation, and later we say P1 equals new point 25. So what happened is you originally have a point P1, you point into an object that's 3, 4. Okay, you do a lot of calculation and later you create a new object that's called 25. So you kind of pointing this one to here, cut the original point. So this object is like an open. So we call this one dangling object. Is that okay? Dangling object is an object no one is pointing to. A building has no address. It's an abandoned house. Is that okay?
Yeah.
And in the long run, Java virtual machine will clean up the dangling object. you recycle the memory for other use. So they'll kill the object and then recycle the memory so other people can reuse the memory. Okay. Others will reuse the memory later. That's called garbage collection. Okay. Garbage collection is one of the features for Java language. Okay. C# language by Microsoft also have garbage collection, but C doesn't. C++ doesn't. Okay. You got to know about it. The dangling object is the main feature for Java. So that's garbage collection. So your integer array M, and the integer A is a primitive data type. So it directly stores a string. While integer array N, it is a reference variable. It may store null, may store the edges of the object, and then you are pointing to the array of objects. Is that okay so far?
Yes.
Okay. So this is the difference between the primitive data type and reference data type. So next one is like there are different classes. There are different kind of classes. You have main program classes. So a program with main, that's called main application program. You may have a tester, so you may have a point class. You may have a tester point. That's your test or demo program. So sometimes you call test point, sometimes called demo point, sometimes called run point. Okay, sometimes called run point, sometimes called demo point, sometimes called test point. Okay. And there may be library functions, utility function you can use, just like math class, java.util. These are the functions that people write for you to solve problems. Okay, and usually you don't do this, you don't do math, you don't do new math, that actually is wrong. Math cannot be created an object. It's a class just providing service. So there's a utility class that you can use, okay? Typical one is the math class and the array class. And then data class. Data class is the point class that we use that's called data class. A class used to store data. Program class is the same as the main class. It said that there are some class only has function but no main. If there is no main, we call it program class. Okay. So these are just rough classification of different classes. And then maybe class help classes. So originally you have one class, now you actually design a delegation to help you to do programming. Okay. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9 are different classes that you can design. Okay. So main application class must have public static void main. That is where you start your program. Tester class must have a tester. So tester is usually we draw a diagram like this. There is a DUT. DUT is design under test. Design under test, such as a point class is design under test. So tester point is this tester class. So you use the tester point to test the design under test. Okay, any question?
No.
Let's try another one. So here we do have a point class, right? We do have a tester class. But it's also possible that you do create, okay, right here, you actually right click, you can do create test class, and some green one pop up. Let me show you the green one. So it's a different class associated with that class. Let me move it a little bit, okay? So as you can see, the green class is moving with my point class. If I move my point class, the green class is moving with it. This one is a unit test class. So you will associate with the unit test programs. Okay, and then there's a setup, there's after, there are tester programs that you will help you to do testing. Okay, so this one called point testing, and then you can define your basic variable right here and do testing over there. Okay, there's a before test. There's a after each, there is a breakdown. Okay, so let's see. There's a so equal, a so equal is let's try this at the test. Okay, so this one, we will do a very simple test of a certain equal 27 and cube 3. Okay, so let's actually run it, compile, and run test all. Okay, it say point test pass everyone, test 2, no error, pass. Is that okay?
Yeah.
So what do you learn from here? What do you know about this J-unit test? Where do you see similar thing like this? Anybody know? This is a test class associated with the point created by. So you right here you can actually create a new class, and then the new class you can actually create a tester class, and the unit test class will come out, right? So this is a tester class. Where did you see this kind of testing before? Everybody use it before, you just don't know. It is your coding bag. If you go back to your coding bag, You're calling back Java, whatever function it is. Okay, so you're calling back right here, you have another OK, right? Green one. So basically, this one is the input calling of the function. So this one is on the right-hand side. The assert equals right-hand side, and this one wrong is the result. So basically, you give certain input and checking if the output is the same with the expected value. Is that okay?
Yeah.
So this one, JUnit is used for to creating some environment to do vector testing like your Java. This is called Java coding back. So you basically one vector in, output vector, is that the same as your expected result? Yes, the same, then correct. So sometimes you forget to put a space. Sorry, that's wrong, right? They are trying to do this. So if you are interested in this kind of JUnit testing, you can go to YouTube. Okay, YouTube has tons of JUnit. You just type J is Java, okay? So JUnit. I'm sorry for the video. You just type JUnit 5 tutorial. 5 is version 5. Okay. There are tons of JUnit 5 tutorial they can teach you. Okay. There are also JUnit 6. No JUnit 6 up to 5. Okay. And then if you don't like JUnit, say you have a Python program, right? Your Python program, there are also PyUnit, so PyUnit. So they are Python unit test. Okay, they are PyUnit that you can do Python unit test. Okay, PyUnit. If you want to do CPP, there are C++ CPP unit test. Okay, these are CPP unit tests. Anyway, this kind of unit test is a object-oriented method to test your object. You can write your own test point class. You can also use the unit test classes provided by Java environment. I use this BlueJ because BlueJ do give you very good unit test environment. Okay, is that okay? For students, it's very good. Okay, it's very easy to test it. Okay, anyway, this is okay. Let's go through a little bit faster. The utility class, we have it. Data class, we talk about it already. Program class, GUI, we will talk about it. The Java library, we use AWT. Okay, sorry, I'm a little bit over time. If you cannot stay for longer, you can quit earlier by yourself, okay? But I'm going to continue. So the point class from AWT is from library, okay? I don't want to spend too much time here. Let's actually go through it a little bit quicker. These are the classes that would be tested in AP Gen: object class, integer class, double class, string class, mass class. These are tested. These are not tested, but very important classes. Usually you need to know in AP as well. This one, not tested, but very important. That means, for example, like print writer, if you don't know it, it's very bad. But will AP test the print writer? No, AP don't test you the print writer. Say set. Will AP test the set? No, AP won't test you the set. But if you do user code, you need it. Okay. Stream builder will AP test stream builder? No, stream builder will not be tested in AP, but if you do user code, you may need it. Okay, these are those kind of the classes. Okay, this array of object and object array, let's save it for the next time. Okay, we probably too long now. Okay, that's too much. Okay, let's go up to here. Okay, single class design. Next time we will continue from array of object and object of array. Okay. Any questions so far?
No,
No. Okay. Good night then. Bye bye.
thank you. Thanks.
You,
You.
bye.
Bye bye.